everyone, welcome to Building Trust in Your ML Models in Production with leveraging ML observability and performance tracing. Steve G said, I'm Amber, a machine learning engineer at Arize, and I'll be running you through this workshop today. Sign up for your free account if you haven't already. You'll be able to follow along throughout this hands-on workshop, and you'll also have access to the account after the fact. So sign up for that. Maggie from Arize will also be dropping in some links to sign up for that free account. And I've also plugged in our community Slack here. Maggie will be dropping that link as well. In our community Slack, we talk about all things ML observability, Arize, and really keep everyone up to date on the latest in ML observability, and our community is pretty active, so come join us. The agenda for today, we're going to talk about challenges with productionalizing machine learning models. We're going to go through a specific industry use case, and then we're going to talk about the applications of these key ML observability principles like in the Arize platform. So you'll get hands-on experience with performance tracing, drift analysis, data quality, explainability, and fairness and bias. So if any of those are like very relevant for your use case, definitely ask questions when we get to it, but we'll be able to probably cover all of those in the hour today. So we're all here today because taking your model from research to production is hard. If anyone has experience taking their models from research to production, love to hear that in the chat. I love like these workshops to be interactive. So if you have had experience doing that, like let me know. If you put a model into production like on a Friday night, you don't have to say if you've done that, but I think we all know the difficulty of trying to put a model in, especially on the weekend, because everything can look great in your notebook. You could be doing the experiments, doing the tracking, like everything works perfectly until you put it in production. The reason we don't want to put these into production like on a Friday night is that we don't know how these models are going to react to the real world, and really no way of knowing exactly how your models will start to behave, if your models will start to drift, if performance will start to degrade. So being able to proactively monitor your models in production is key. So Arize did this very large survey, over 1,000 companies surveyed, machine learning engineers surveyed, and because we wanted to see what is taking the most time in production. And when you're finding these errors in production, how long does it actually take you to resolve those? We found that 84% of teams say that it takes at least a week to detect and fix an issue in production. And with the Arize platform, like we wanted to see if we can take, that week, condense it down just into a few hours, and within a few hours being able to see what's wrong with my model and can I actually resolve that like just in a day. So taking that time to value, because having over a week, which your customers are experiencing this issue, taking an over a week to figure out where this issue is, try and figure out how to fix it, that's just like a lot of troubleshooting, and it's not really conducive to the machine learning work that you were hired to do. So making sure that teams are well equipped and being able to just resolve this issue in, like I said, just a few hours really is important for your customers, the profitability of your company, and just to make sure that if you're a machine learning engineer, like your time is being spent in like the model phase and not just in trying to figure out where this error is happening. And a lot of this comes from time spent on ML in the past 5 years, where a majority of it is on the data preparation, the model training, the model deployment phase, and very little is actually spent in the production. We find that teams spend on average less than 1% of time in that production workflow, and that really comes from all the challenges that teams are facing. So the time it takes to actually resolve these issues, having the right alert system, and what we find is the main challenges are in a few specific areas. So the common problems that plague team are around model and data drift, data quality issues, performance degradation. If anyone here has experience in these, or find that their biggest issue is data drift. Their biggest issue is data quality. Let us know in the chat. Like, again, want these to be interactive. And if you have any questions throughout, just pop them in there and I'll be happy to answer. So with the stages of the machine learning pipeline, so we talked about data prep, model training, model deployment, where there's very highly specialized developed tools for each part of that machine learning pipeline. The issue with that last mile, that ML prediction, operational decision aspect, is that there's not a set of tools that used to exist like 3 or 4 years ago to be able to monitor your models in production correctly. And so what teams have done is kind of string together a list of existing tools. And the issues with these is, although they're great tools, a lot of them weren't built for the specific task of monitoring in production. And the integration aspects of trying to repurpose an existing tool, can create a lot of headaches for engineers. But I would say most importantly, like if the tools aren't designed specifically for that ML observability task, they're not going to be able to alert you to the, where your focus should be. And that's really what's key, like you being able to know where those issues are, even if it's something you haven't seen before. So being able to really hone in on like common errors in industry, even if it's something you haven't seen personally. And that's really that last step. So being able to say that last mile is about ML observability and then looking at ML observability platforms. So I've used the term a few times now. I just want to give you an actual definition. So ML observability is a software that helps teams automatically monitor AI, understand how to fix it when it's broken, and ultimately improve data and models. And a lot of teams will use ML observability and ML monitoring kind of interchangeably. I just wanted to say how the ML monitoring is more the tip of the iceberg. So being able to tackle, like performance and drift and data quality is very key. Like you need to be able to have those monitors set. That's definitely step one. But then being able to actually root cause that issue, that's the level deeper, and that's where ML observability actually comes into play, where it's not just a red or green light on how your model's doing, but helping you figure out where your model is underperforming. All right, again, for those that have recently joined, we're going to be walking through a hands-on workshop. So use the sign-up link. Maggie's also dropping the link in the chat. So you can get your free account. This account isn't just for the workshop. You'll be able to use this free account to troubleshoot your own problems in production. You could upload your own data after the workshop today, play around with it, and like all the Arize platform features are available in this account. You just might not be able to put in, you're not completely able to put in like your full production data into the free version. But if you are interested, we can move you into the enterprise tier. Okay, thank you for that, Maggie. And so we're going to be diving into the platform after this use case, but I really want to know if there's particular areas or like what you're hoping to glean like from this workshop, so I can make sure that educational piece is covered. Because while we will be in the platform, we're going to be talking about all things related to ML observability and the key parts to keep in mind. All right, so we're going to be talking through a fraud use case today. So you don't have to have any experience with fraud, but let's say that you're a machine learning engineer at a bank, you build a model to determine whether or not a customer's card transaction is fraudulent. We're going to be looking into monitoring this in production. And the reason we want to monitor this in production is because of the KPIs that could suffer. So does anyone have an idea of some KPIs or key performance indicators that might suffer if you fail to monitor for this correctly? Or if you were just a customer and you've had transactions denied, or you haven't had fraudulent transactions denied, like what kind of comes up there? Like what does success mean for like this machine learning engineer? If you have any thoughts on that. For the kind of the most common ones, like being able to look at chargebacks, being able to look at customer satisfaction, because there is a fine line. You want to make sure that you are able to make a model that isn't flagging everything, but it is flagging the fraud that you're looking at. So making sure you have that balance is going to be key for your ML models. And does anyone know, like, or have an idea of what metric they might want to use? There's not wrong answers here. Again, just wanting it to be interactive. I know a lot of us are like work from home, so just getting kind of like conversation going for popular metrics you might use. A lot of the metrics that teams will monitor for, like accuracy, performance, recall, precision, false positive rates. We're actually going to be looking today at a false negative rate, also known as the miss rate. So this is like the probability a true positive will be missed by the test. So essentially, the higher the rate, the more fraud slipping through the cracks. So an ideal false negative rate is close to 0 for this case. All right, again, yeah, just last plug. I see a few more folks have joined. We're going to be doing the hands-on walkthrough now. So sign up for your free account and join the Arize community Slack. All right, so for the next, let's see on time. Yeah, so about the next 45 minutes, we're going to be diving in the platform, getting your questions answered. I see we do have a question in the chat. Jolene, I'll get to that in 1 second. And being able to like not only root cause, but also figure out like how one would resolve that in production. All right, we've got some questions here from I think it's Charlene. Thank you very much. Oh, GPS Bluetooth location as a KPI, yes. So absolutely, like, all those can actually be entered in to the Arize platform. I'll show you like what that can look like here. So I'm going to go into the Arize platform now. So if you have created your account, you can go in directly. Maggie will be continuing to drop that link to make sure you can get your account created. But you'll first log in. You'll see the models live, the prediction volume, the model version seen live, and these are all example models that Arize already put in the platform for you, which you can go through, you can play with, you can set your own monitors for, and then again, you can add your own data. So going back to the great questions we had in the chat from Charlene, you can go through each model and enter any of those features, any of the metadata, and actually embeddings as well into the Arize platform. So if we go into our fraud use case, for example, here we're going to see the overview. This has our performance over time, our model health, and then whatever we're entering into the platform. So the great thing about the Arize platform is that you don't have to upload the full model. So anything that's written in PyTorch or TensorFlow, or a scikit-learn, you just need essentially the data in. So it's a data in, data out. So as long as your data is in a readable format, you can send it to Arize with a Python SDK. We can pick it up with cloud storage integration. You will just have the SDK option for the free account, I believe. But again, if you wanted to talk more, we can absolutely connect and talk about how you would be able to set up like a cloud storage integration. But with the inputs, so you're going to put in your predictions for your model. So specify your predictions, and then we'll do a quick calculations on your drift and your data quality. So for our drift, we're using a PSI, or population stability index. It's one of the most robust ways of measuring drift, and we'll get into drift in just a little bit. Want to focus on the performance tracing aspect first, and then we'll get into each one of those categories. You'll want to log in your actuals. Now, I know not every use case that you're using is going to have actuals, but a lot of them will eventually. So if they do have actuals eventually, you can link those back to the Arize platforms. Actuals are not necessary, but they are necessary for performance. Not always, they're not going to be necessary for data quality in production or for drift. And then we have the features. So GPS, which was mentioned in the chat, that's a great one. Yeah, and absolutely something that you can use, especially for fraud. I wonder if that's even one we have on here. These are just example toy data sets, so these are all mock. but that's absolutely something that we could have, or even tagging. So tags here are just an example of metadata. So if we wanted to add like a, like geolocation tag to like an ID, we can do that as well. All right, any questions so far? I really want to make sure like everyone's questions get answered, because I know with these like virtual sessions, it's easy to kind of get lost or like zone out for a second. You come back and you don't know what just happened. So yeah, keep asking questions as we go through the platform. Or like I said, if there's particular things you want to know about, or you came to this, you saw ML observability and there were some questions you really wanted to ask, just ask them. Whenever someone asks a question like that, other people were always thinking about it, and it's always great to have that, because I'll always cater to the educational questions that are being asked. All right, great. So we covered a lot already. So that is going to be like kind of the overview. With our overview page, you also have the performance over time. You might see your account to not have the alerts up yet because you just created it. So for that, you'd go through, you do your setup model. You select, like we were, I think, selecting a false negative rate for our default metric. You would select fraud as your class. You could turn on all your monitors, and if you want to send alerts to yourself, you can. This is optional. We also reach out to Slack, email, PagerDuty, just the easiest way to reach you and your team. So you have all those options as well. And then you can just finish. They set up, you'll see they set up within like 10 seconds, and that's setting up monitors on drift, data quality, and performance for every single feature in your model. And we also have the capabilities to set it up for metadata as well. All right, great. So let's go back into our fraud use case. So we're seeing our performance over time, we're seeing our false negative rate, we're seeing our model baseline. So this model baseline that you're going to be selecting is going to be key for your drift monitors. So you'll need to be able to set that up for your drift monitors, and you can reconfigure this however you'd like. Most teams are going to use their training set for their model baseline, but that could also be a window on production. So sending in training and validation sets are completely optional. So you don't have to send training and validation sets. A lot of teams will choose to, because you can do version control with the Arize platform. So constantly viewing like different versions. We'll get into more of that later on, but selecting your baseline. So if you did like submit your training set as its own version, you can select that. You can also select any window on production. So if you're looking at a set window on production, you can move this to correspond to your retraining cycle, and this can be a fixed or dynamic moving time window. So that can all be set. And you can also change it out as you would like, but most of the time teams are going to use whatever they're training their data on as their comparison for the production data that is coming in. All right, any questions so far? All right, and whenever I do ask that, I do look at the questions myself, so I'm making sure that those are getting asked. All right, perfect. So the title of this talk, being able to leverage ML observability with performance tracing, is what we talked about. So we're gonna get into that now. So you might notice we have a performance tracing tab here. I can go in that directly, or I can look at a monitor that has triggered. So if I go into performance, you can go in directly here, and I can look for a monitor alert. So right now my monitors are great. Any issues have been resolved, but maybe I want to look at something with a historic issue. So if I go into a monitor, I can see that at one point my monitor was triggering. So when you sign up for your monitors, you would get this alert sent automatically to you as soon as this false negative rate has crossed your threshold. And while we do automatically set, like we use smart monitors for all our features, you do have the ability to completely configure your own monitor. So you can add brand new monitors and you can change existing ones. You could change out evaluation metrics, the prediction class. It does depend if you're using a classification or regression model, or if you're just using embeddings. More on that a bit later. But for your production data, being able to change out this evaluation time window, you can use a few advanced settings like select only a given model version, so like a V1, V2, and then any filters on metadata features, and then you can, if you want, you can turn off auto thresholding, which is using kind of an historic baseline to set that threshold, and then you can have those alerts again sent anywhere you'd like. And we integrate with a ton of platforms on that. So I'm not going to save those changes, but I will go in, and so the way I saw that was you can also access your monitors from your homepage. So just to get a concrete flow, if I'm in my homepage, I see that an example a monitor has triggered. I can view those monitors, go into them directly, and now I can troubleshoot model performance in production. So click into troubleshoot model performance. This takes me to performance tracing. You can also kind of have more of a discovery mode. So it depends if you want to kind of go into the discovery mode or that troubleshooting mode. The discovery mode is more, I want to just understand my models better, nothing is triggering right now, but I want to see where my model is underperforming the most. Because if you can understand where your model is underperforming, it doesn't necessarily have to be something that is breaking your model. But if you find a way to improve performance a few % on a working model, that's going to be huge in terms of your return of investment. So being able to look at that, even when your model isn't breaking, is key for machine learning engineers and data scientists to be able to make sure their models are performing at maximum. All right, I'm just going to check the chat here. All right. Looks like everyone is caught up. Awesome. So now we're getting into performance tracing. So performance tracing is actually coined, a term coined by Arize, where we're using a root cause analysis on performance, actually diving in to figure out where your model is underperforming and give you a kind of a triaged, a triage view of where your model is underperforming. So if we look at something like false negative rate, so right now we have the data set A, and this is looking at production, the version, the time period, the metric, and then we have it as a function of volume as well. So these darker shades here, we always do it as a function of volume as well. And then we're seeing our false negative rate. So just a review, we said false negative rate, so the closer we are to 0, the better it is. 0 means no fraud's getting through, 1 means all the fraud's getting through. So we want it to be as close to 0 as possible. And so then we look at our performance breakdown at the feature level. So this is going to tell us each feature, how it's performing, where this yellow / whitish color is going to be our best, where this darker red color is our worst performance. And this works for any metric that you put into the platform. So if I changed it out, which we might change it out a little bit later, it would still correspond to being the correct gradients. So we have this feature importance score. So feature importance comes from our SHAP values. So you can send in SHAP values, or Arize can calculate them for you. But you can send in your SHAP values. We can use those feature importance values as a way to look at explainability and also to triage our performance and our drift. So we have feature performance as a way, you can rank your model by this. And then we have performance impact. So performance impact is going to be the impact of an individual slice compared to the global performance impact. So your false negative rate at whatever window you've selected here, and then the individual slices of data. So being able to look at not just your global performance, but we filter down at the slice level or the input level. So this is our feature merchant ID. And so we're looking at, we can see the volume and we can see how each individual merchant is performing. we'll get a bit more into that in a moment, but just wanted to double check like on the question side. Okay, great. Looks like everyone is following along. So now let's get into a troubleshooting mode, right? Okay, so we're looking at this time window. We do see right here, like there is something that is spiking the false negative rate. There does seem to be some kind of issue here. Also 0.4, it's not great. It's not terrible, but you know, we would like it to be closer to like 0.2. And now we're looking at this most important feature. So these are triaged right now by performance impact. And we're seeing that merchant ID has a very strong performance impact. So it's saying that merchant ID has a slice of data in it that is bringing down performance more than anything else currently in our data set. And then when we look at the individual inputs, the individual merchants, we are looking at for example, like Haley Group, we can see that false negative rate exactly. We can see that impact score and we can see the volume. So we are seeing the false negative rate about like 0.4, 0.4, 0.4. So pretty consistent, except when we get here to ScamEds. So this merchant ID has a false negative rate of 0.9, so almost 1. So very, very high false negative rate, very poor performance. It has a significant performance impact score as well. Like it's really bringing down the performance, and we can see that. And it has a decent volume. So like 8% of the merchant ID volume falls into that category. So what we can do now is either add the cohort as a filter or exclude the cohort as a filter, or view the explainability aspect. So we'll look at the explainability in a second, like as long as explainability is a topic that would be relevant for you. This gives you information into why it's made a decision. So explainability, like SHAP values, line values. So if I want to add it as a filter, then I'm filtering on only ScamEds merchants. If I exclude this cohort as a filter, then I am excluding it, and I can see how it might bring up my performance overall. So again, I'm at 0.14, I'm at 0.41 for the false negative rate. Anything that's lower than that is going to be significantly better for my performance overall. So if I want to exclude this cohort, we see that our false negative rate has improved about 2% just by filtering on that. So we're not deleting any data. We're, essentially this is a mass amount of SQL queries available for a bird's eye view. So all available at once. And you can also add these filters by hand. It's a bit easier just to see what you want to add and then filter by that, and kind of go in and see how this is playing out for your data. You can also add comparisons. So a big part of performance tracing is comparing to a baseline, for example. So we are now seeing our production version and our production version with a filter. So this is just a filter for data set A, and being able to look at these comparisons. I can also choose to make this data set, I can make it any training, any validation, any version here. So it could be any environment, which is production, validation, training, and then any version of that environment as well. Some teams also choose to compare like training to training to validation set, anything in the experimentation phase as well. So right now we're comparing these two different versions. We see that our has about 0.34. So by adding ScamEds as a filter, we really do see that impact and how much closer it is to the training performance that we would have liked to see. I can now get rid of this filter. Still have these comparisons, and now when I go down to the performance breakdown, I actually have a mirrored comparison. So I can go and look at my merchant ID if I make this bigger, and then I can see these side-by-side comparisons here that compare dataset A to dataset B. And you can do this again for any environment and any version within that environment. let me check for questions. Okay, so we seem to be good so far. Yeah, seriously, if there's any questions you have on this, yeah, I'm trying my best to explain it, but I know how difficult it could be, like learning this just through watching a webinar. So if there's anything you notice, like anything you have questions on, if you have a particular use case and you want to ask about it, happy to answer those at any point. Okay, perfect. So we can look at the performance breakdown by features and by metadata as well. So being able to include that as well. And one thing that we have already uncovered is that merchant ID scam ads is having a very negative impact on our performance. So we now know like that's the case, like that it's, that, individual input to that feature has a very strong negative impact. So let's compare it to our training. So here's merchant ID. Here's the different, I'll make this a little larger for you. And we can see, so now we're looking at the training versus validation. If I hover over it, I can see the false negative rates of both, the impact scores, and the volume of both as well. So overall, for our training, which is our dataset B in this case, we do see a better performance, which that is normally the standard. It tends to be a bit better performance when looking at our training version than our production version, but we still want it to be fairly close in scores. And so these other vendors here look pretty close. It's like a 0.03 difference, which is pretty good for our production performance. But now we're looking at scam ads, and we see no data for our dataset B. So what that probably tells you is that this merchant wasn't in our training data set. And so if it's not in your training data set, there's no way for your model to make reliable predictions on it. So you want to really figure out, this data, like the impact it has, and then use it to retrain your model if it's something you want to look into a bit more. So we saw like how you can add this as filter, how you can exclude it. Let's actually dive in a little bit deeper here. We can also choose to get rid of any of these additional environments if we like. So if I go now into my merchant ID, I can view like the explainability aspects as well. So any more questions on performance tracing, we will continue to go in, but like the main principles that you saw is not only can I compare any environments, compare how I expect things to look to how they are currently looking like at this, this second in time, but I can then triage, focus in on the individual slices, see which slices are performing the worst. So which features, which inputs in my entire data set are performing the worst, focus in on them. I can then filter on them to see how I'm doing. If I'm filtering on something and I see like that could bring up my global performance by 2%, and I know each percent is equates to X million of dollars, that being able to like hands-on like show that, and then just knowing you need to go in and like fix the data that surrounds that is a really large step for data science teams, machine learning teams, because you don't have to spend days or weeks actually, doing the SQL, trying to figure out, testing each feature, trying to figure out where this model is underperforming. We give that to you directly. Okay, I'll check for questions. All right, great. So we do have a few more questions. Awesome. I'll go through the explainability part just real quick, and then we'll head back to answer these. Thanks, George, for putting those in. So looking at the feature importance, so like the explainability parts. So if people are familiar with SHAP values or feature importances, like the SHAP value is going to tell you how much each one of your features contributes to the prediction. So it doesn't tell you anything about performance, doesn't tell you anything about actuals. What explainability does is tell you the features that are most responsible for making a prediction. So when you have like a high value, you know, you're essentially saying like, okay, this is like the most important feature for my model. And you can have different levels of explainability. So you can have local explainability, which is at the event level, like this particular loan was, you know, flagged or didn't go through for whatever reason. You could have at the cohort level where it's, oh, everyone over the age of 30 is getting like this result. Or the global level. And the global level is the most used because it's saying like this feature overall is having the most impact on my predictions. So it's the most important feature. So explainability, feature importance, same thing. Feature importance is, I think, more commonly said as like, you know, kind of the ranking system. Explainability is the methodology behind it. And then SHAP is the calculation that's used. So just a bit of background there. And we can use this to compare different data sets and to see the impact it's having. So if something's having a very strong global impact, you know, and it's different from like training set to production set, being able to hone in on that could tell you a lot about the predictions. And then going back to our performance tracing, this is what we do use here for the like feature importance values. All right, let me look at the questions we have in our chat. Thanks, George, for saying it's a great session so far. Hopefully everyone is enjoying it and following along. Will you talk about where the model is hosted and how it's used to power your platform without performance metrics? Okay, yes, so great question. I'll also take this time to point out our documentation. So these are docs.arize.com. Maggie can also like just drop this link in the chat. These are available for everyone to see, and a lot of questions around use cases, examples, like if you want to get your own data into the platform, we have a ton of examples using the Python SDK that you can leverage to get your data in. Also have examples on quick start guides, you know, each part of the platform that I told you about, and then the data ingestion. So George is asking about where is the model hosted. So for the like Arize platform, there's a few options. For first, we do have some, you know, we do have on-prem customers and we do have SaaS customers. So the model can be hosted wherever you would like it hosted. I think a lot of teams, more teams I think are starting to move to SaaS, and like, you know, that's great. And we do have all the compliances necessary for hosting, like for hosting the Arize platform in-house. So for where your model is, so with the Arize platform, again, like you don't actually have to upload the model itself. So we'll take the data surrounding the model, and then we'll take that data either through an API, an SDK, or a cloud storage integration. So you send in, I think that's probably just at the top here of what you can see. So for what you're logging into the platform, so we'll take all your data, so your features, your metadata, your SHAP values, your predictions, and then if you do have those actuals back, we will take those into the platform as well. And yes, the model can be hosted on GCP, AWS, and Azure. Great question. All right, awesome. So let's pop back in to our demo. So now we've talked about performance tracing. We talked about explainability. Another aspect that people really like, so let me just kind of, let's see. I'll make this like the last one. So you can select any time frame that you would like for these models. You can select it, have that be a comparison, and then you can add an additional comparison to it directly. I think everyone can still see me. My connection's being a little slow. But if I go in, go back into performance tracing, add a comparison, I can also zoom in on these underperforming segments and then just look at the data of that segment, either versus my production overall or against my training or validation environment as well. And I know we talked about features, we talked about tags. One other area that you know, we haven't gone into are unstructured features. So we do support unstructured models. So we do have an embedding drift, and we have an event next week. So it's next Wednesday. It's going to be Arize Unstructured, and we have OpenAI talking, Hugging Face talking. That could be really interesting. I know like several people here, like they do have classification and regression use cases, but they also have some unstructured use cases as well. So Maggie's going to drop the link. You can sign up. It's a virtual free event. It's a couple hours and really talks about how teams are leveraging unstructured data in production and monitoring for that, which it's very hard to do. So just you know, something interesting that might be relevant for a lot of you folks, and Maggie will drop the registration link in the chat. All right, so we talked about performance tracing, we talked about explainability. For the folks on the call, like, you know, next we can talk about drift, we could talk about data quality, we could talk about fairness. I'm curious, like, what areas that you're the most interested in, either learning about or, you know, for your own specific use cases. So if you have particular areas there that you want to cover in the last 15 minutes, otherwise I'll just dive first into drift and we can go from there. Great questions so far. Okay, so when I'm back to my overview of the platform, so like I said, we have monitors set for drift, data quality, and performance. All these can be changed, all these can be monitored directly. And if I want to go into my drift monitors, I can see that one has triggered. And if I go into this directly, I can troubleshoot drift from my drift monitors. So we have a drift tab, and you have the ability to go in there in that exploratory mode. But if you do see an error that had occurred, you can look into why that specific error had occurred. Yeah, if you do sign up for like notifications on your monitors, you would get an alert as soon as the monitor did trigger. And just like with performance monitors, you can edit these monitors however you would like. You know, you choose the monitor name, the model, the current you know, you can see the current distribution down here. So this is going to be your distribution comparison. So whatever you selected your baseline to be, that's what your performance is monitoring against. We have automatic thresholds. If you would rather not use an automatic threshold, you can turn these off and use something like a standard deviation. And then you can send the alerts wherever you would like. And we have a few like advanced settings as well, like a look ahead period, or if you only want to monitor a top like 8%, you can do that as well. So looking at the baseline, so this is the one we selected, you can change these out however you'd like, and you can add multiple you can add as many monitors as you like. We are a consumption-based pricing model, so volume, our pricing is all available on our site. Maggie could probably also like drop that as well. Free account, you have access to all this and as many monitors as you would like. So definitely, you know, sign up for that account and test out for yourself if you haven't. You can also duplicate these monitors and play around with them. But if I want to now, like, I'll just cancel these changes. And if I want to say, you know, go into drift directly, I can either choose my drift tab or go into there directly from these alerts that have happened. Because if I click troubleshoot drift for a particular feature, it's going to take me into that feature. And then now that I'm in this feature, I can look at the drift over time, the PSI, so our population stability index, our traffic, and then our false negative rate if we do have those actuals back. So if we have those actuals back, it's a great thing to have. You know, you could be able to look for, you know, is the drift that you're seeing, like, is that corresponding to a degradation in performance? Because if it is, that's what's known as concept drift. But we support all different types of drift. So being able to look at drift at the data drift level, so that's your feature drift, that's your input drift, that's your metadata drift. Being able to look at your prediction drift, so drift in your predictions over time, and then what I also call upstream drift, so like a kind of a drift in the data that you're expecting to see. So being able to kind of layer these on and then view these distributions, so we can see where there's no drift, So this is a very low PSI score. We're seeing, we also happen to be seeing like a low false negative rate. We're seeing the traffic, and we have 72 hours as our set, but you can reconfigure this. And then we can see that these distributions are pretty close. But when we actually get drift starting to happen, we can see how these distributions start to change and how they start to diverge. So once these two distributions diverge enough, that increases the PSI. So the essentially the statistical difference between these two distributions, and there are other ways to measure, but PSI tends to be the most robust. It is also derived from KL divergence and has a symmetric property, which I don't know if no other metric has it, but none that are as robust and as good at looking at categorical and numeric features. So the symmetric property pretty much means if I compute it with the green distribution first, followed by the purple distribution, it will give me the same number. Whereas for other calculations, it matters which distribution you put in the equation first, which doesn't make it very robust. A lot of folks have used KL divergence, which is great for two very different size distributions, like if you have one very small and one very large distribution. But if they're similar in size, using a PSI is going to be your best bet. Let me look to see if there's any questions on that. All right, great. Thanks, George. These are great questions. Yeah, keep them coming. Okay, great. So we have another question. This one on some models, so like tree-based models for observability and interpretability. Yes, okay, so this question pretty much is pointing out so there are models that are better for interpretability than others. So things like tree-based models are great for interpretability because you can easily explain them. You can look at them directly, but black box models are not as forthcoming. So do we, do we cater to, having dashboards based on what the model is used and if it's model agnostic? That is a great question, George, and that's very true. So the level of interpretability is going to depend based on your model. So as long as it's a model that's making a decision, whether it's a neural network, a regression model, a classification model, as long as it's making a decision, you have, first you're able to look at drift to see if anything is drifting. Drift is our best proxy to performance. When you actually have that performance, you can create our dashboards. So let's actually go and see our dashboards. And just to point out here, so pretty much covered looking at drift directly. You can also overlay, oh, it locked me out. 1 second here. And you can actually create the talking and typing, always difficult. You can also be able to create dashboards directly for these. So if I go onto my fraud use case, okay, I currently didn't build any dashboards yet. So I can go to dashboards. We also have a lot of templates as well if you want to create a dashboard there. If anyone's familiar with Grafana, our dashboards are very similar to Grafana. They're fully configurable, and you'll see what I mean in just a second here. So if I want to create a blank one from scratch, I can do that. I can also select, so this one is like a scored classification model, but you can create them from scratch, and we do have teams do that as well. This one is just a template, so it's going to create a lot of things just for you off the bat. So it's the model that I've selected. I can select any version I want. I'm just going to select all the versions. I could select particular features, but I'm just going to select all of them because I can also filter on my features in my dashboards. So I can create this dashboard. These are very fast, very functional. I can edit these as I would like. So any time series, distribution, or statistic metric, I can add, I can rearrange, I can reconfigure, just however I want these to look. These are also collaborative, so you can, based on your space, so we have like orgs and spaces. So based on who has access to that, they can also, have collaborative dashboards, or you can each have your own dashboard. You can make as many dashboards as you want. It's definitely not limited there. And then if I want, I can continue to edit these directly. I can add plots on top of each other. So really like a lot of flexibility with it. Mostly because teams want to be able to edit these however they'd like, being able to select the environment, kind of an aggregation function if you'd like, filters. So that's very much still based on filters. Like Arize really prides itself on being able to continually filter down until you find that error, or track for very specific inputs to your model. So you can also continue to stack plots, add plots like overlap if you'd like to do that. What's also nice, being able to, okay, I'm gonna not edit that anymore, but being able to select your use case, select the versions, and maybe, I want to filter by home ownership when it's equal to like a lease, for example, because we did also see that was bringing down performance a lot. So you can continue to add filters as you'd like, and they save in a few places. Like if you go to your home, you can see all the dashboards that you and your team have created, or you can go to like all dashboards and all templates offered by the Arize platform. All right, great. I did see like there was another question here. Okay, perfect. So it looks like I answered that one. So yeah, just depending on the model that you have, we also have like, in the docs, like different common use cases. So as long as your data fits to a given use case, that's kind of how we put them into the platform and how we triage them. All right, so now we've covered performance, we've covered a lot on drift, explainability, our dashboards, our monitors. Let's go a little bit more into drift. So if you go to the drift tab, just straight to the drift tab from our homepage, what you'll see is our prediction drift over time. If there's any questions on drift, please let me know. Like, I really enjoy talking about drift because drift is going to be the best proxy we have to performance until we actually have those ground truths and can compute our performance metric. So drift is going to be great for monitoring and for root cause analysis as well, because you can do root cause analysis before you have that performance information. It just it can make it a little bit harder, but having drift is so much better than not having a set monitors. So being able to have drift, being able to go through, look at your prediction drift over time, because again, prediction drift over time, you don't need your ground truths for. It's just seeing like how your models continuing to make these predictions, which you don't need the ground truth for. So that's like the first type of drift we support, prediction drift. And then again, the second type, looking at concept drift. So concept drifts that happen a lot in the pandemic, like when the actual environment itself was starting to change. And so, looking into that. And then feature drift. So looking at the drift of individual features. So for, like I mentioned earlier, for each feature, we compute the PSI, we compute the drift, we have the performance importance, or the performance, we have the feature importance. So individual importance of features, which are from SHAP values. And we can either calculate that SHAP value for you, given a surrogate model, because again, you don't have to actually upload the model itself, so we can compute it for you. Or what a lot of teams do is they're already computing their SHAP values and they'll send those along. And then we have this prediction drift impact score, which we get from multiplying the feature importance by the drift. So by multiplying these two together, we give a prediction drift impact score, which is a way to triage how a model is doing. So by looking at what individual features are drifting the most, can really help you understand the errors in your model before you're even getting those results. So say you have like a churn model, or something, you're not going to get those results back to, say you have a 30-day churn model, you won't get those results back until after those 30 days. At least not like the full results on how well your model did. So being able to look for drift of users, like, oh, you know, they're starting, like that behavior is starting to change, or the behavior in this region is starting to change. Being able to combat that before any major results and like major impacts start happening is going to be key. So if I click on an individual feature that has a strong prediction drift impact, I can see that, you know, I can see where it's starting to take place. And then clicking on these individually, I can see the difference here. So I have my current distribution and I have my baseline distribution, and I can see how that's actually starting to change. And I can see when there's no drift. When there's no drift, things are looking pretty similar. It's interesting here because we are seeing some like a high false negative rate, but we're seeing that that doesn't relate to drift. Sometimes you could have a healthy amount of drift, and sometimes any feature that starts drifting could have a major issue. And again, you can look at the data quality aspects as well to confirm cardinality, percent empties, and we do a lot of other data quality monitoring in production. All right, so we have 2 minutes left. Let me double check for questions. Okay, so it seems like everyone had gotten their questions answered. First, just want to thank everyone for taking an hour out of their day, like coming to see this. It was great. I loved the questions. It's always fun doing a presentation on this platform because I was a machine learning engineer. Like I put models in production, and then you know it's pretty scary once you do that. And like being able to have something like this that you can fall back on, that you know really just saves you so much time and energy, and is actually fun to use, was really a game changer for me. And a lot of the members of our community also feel the same way. So we'll just drop, you know, a few more links. You know, these are ones you might have already seen, but sign up for your free platform. You can play around with this however you like. And then if you are interested, you know, you'll be prompted like to kind of contact us if that's something you're interested in, and we can go from there. And again, the event next week is going to be our unstructured data. So if you do have more unstructured use cases, definitely attend that event. And there will be a lot of awesome guest speakers. There will be some prizes. So please, you know, if that's what you're really interested in, that's going to be the best time for you to learn. And then yeah, I would say join the community, and it'd be great to keep talking with you. We also do have hands-on workshops for each category I did talk about today. So we didn't talk a lot about fairness and bias, but next week there's an entire workshop that's a 30-minute live workshop with me dedicated to going through that. All right, well, we just have 30 seconds left. If there's no more questions, I want to thank everyone again, and I hope you all have a great rest of your day.